In this video, I'm going to discuss about the power dissipation of the microcontroller, which is one of the important criteria while designing the embedded system product. The power dissipation of a system is a major concern for the embedded system designers, especially while designing the battery operated systems, because the life of the battery depends upon the power consumption of the system. The power dissipation is a function of the frequency in addition to voltage and current. So power dissipation P is given by voltage into current, and how this power dissipation is related to frequency here we can derive. And we are considering a charge storage device which is given by Q equal to C into V, and if you divide with time on both sides, so Q by T equal to CV by T, where 1 by T equal to frequency and current is given by charge by time. So this equation turns into this I equal to CVF, and if you submit current in power dissipation, we are getting P equal to CV square into F. So from this equation we can know that the power linearly increases with frequency, and it also increases square times with respect to the supply voltage of the microcontroller. Here you can compare the power dissipation with respect to the supply voltage of the microcontroller. So there are two microcontroller systems with 3.3 volts and other with 5 volts DC supply. And the power dissipation is given by V square by R. Here for understanding we are considering R, that is resistance, as 1 ohm. And for 3.3 volts power dissipation is 10.89 watts, and for 5 volts power dissipation is 25 volts. So here you can clearly see by operating at lower voltage, the microcontroller power consumption can be reduced. So how power dissipation can be reduced in sleep mode of the microcontroller? So here you can see two major currents will flow through an IC. It can be microcontroller, it can be a microprocessor or any other digital semiconductor IC, and these are dynamic and static currents. Dynamic current I is given by CVF, which we have discussed earlier, and this is a function of the frequency under which this microcontroller or digital component is working. And that is static current, also known as DC current. This is the current consumption of the IC in inactive state, that is whenever it is not performing any operation. This can be considered as a leakage current of the IC. The dynamic currents are much higher than static currents. So to reduce the power consumption, many microcontrollers use power saving mode, also known as power down mode, also known as sleep mode. So in sleep mode, what it is being done? So the dynamic current is reduced by stopping the on-chip oscillator, which further cuts off the frequency to the CPU of the microcontroller and also the other peripherals that are present on the microcontroller, like serial port, timers and SSP, etc. The microcontroller, once entered into the sleep mode, it should be again waked up. So this can be done in different ways, by performing the reset operation of the microcontroller and watchdog timer wake up, and also there are peripheral modules like ADC, external interrupt pin, comparators, timers, synchronous serial port, etc. And these interrupts can also be used for waking up the microcontroller from sleep mode. Thank you for watching my video.